Alright, so the last thing that I'm required to show you in Chapter 7 is 7.5, which deals with what's called a conditional proof. A conditional proof is a way of dealing with a argument to try to prove its validity based upon the conditional statement that it concludes with. Now, if we look at the problem on the board here, we have if A, then B and C. B or D, then E, therefore A, then E. And the basic idea here, of course, like always, is to take the premises that are presented to us and try to yield the conclusion. Now, many times with these problems, there is a simpler way of doing it, and as I kind of showed you last time, I always prefer the simpler solutions. I mean, I could do this as is with our basic rules. If we take line 1, you have if A, then B or C. I would simplify that to make it if A, then B. And then I would use addition to add the D. So if A, then B or D through 3 through addition. And now we have if A, then B or D then E, therefore if A, then E from 2 and 4 modus ponens, and we're done without any fancy shenanigans taking place, without having to use a conditional proof. So a lot of times there are other ways of doing this. But again, the book wants you to learn, and the college wants you to learn, the concept of conditional proof. So that's what we're going to look at here. To do a conditional proof, you have to have a conclusion which has a conditional statement. So in this case, we have if A, then E. So what you're going to do on your third line is you're going to take the antecedent, which in this case is A, and you're going to list that as A, C, P, assumed conditional proof. Okay? This is the whole thing that we're going to do is based upon the assumption that the antecedent is true. So we've got an assumed conditional proof of ACP. Now, because this is conditional, everything that we do from here on is going to be indented, and it's important that you indent that. So line 4. But from here on, basically, you're just going to go ahead and solve as you normally would with these problems, using this as a new premise that we can work with. So lines 1 and 3, if A, then B and C, A, therefore B and C, from 1 and 3 modus ponens. Now I'm going to simplify B and C to B. What I want to do is start with the A that's assumed and try to work my way to the E. And so I want B or D then E, so we'll take the B from line 6 and we'll add an E, right, 5 through addition. And now lines 2 and 6 make a modus ponens. B or D, sorry. B or D then E, B or D therefore E, 2 and 6 modus ponens. Now, since I started with the A, the antecedent, and was able to use these rules to work to the consequent, which is E, I can now, coming back into our original line on line 8, I can conclude if A, then E, based upon 3 through 7 CP, conditional proof. Okay? And that's really the idea behind a conditional proof. Ideally, you should be using these when you can't solve it in a normal fashion. But again, you have to have a conditional. You start by assuming the antecedent of the conditional, and you work until you reach the consequent of the conditional. If you're able to do that, right, through that process, then you are able to conclude conditionally that your argument is in fact valid. All right? And that's basically the way that a conditional proof is going to work. So let's go ahead and take a look at exercise 7.5 right around page 441. And we'll work one of these here with you, maybe a couple of them, just to make sure we got the basic idea here. So here's the first one. We have if n then O, n then P, therefore n then O or P. Then O, N, P. Okay. All right. So now, looking at the conclusion I want to reach, which is n, then O, N, P, all I have are these two conditional statements, so under traditional method, there's nothing I could do in this case to get that conclusion. So I am going to have to use conditional proof here. So I'm going to start by taking the antecedent, the n, and again ACP, assumed conditional proof. And then I'm going to start working the problem as normal, trying to reach the consequent of O and P. So again, remembering to indent on line 4. Well, N or O, N, therefore O, right? 1 and 3 modus ponens. The same thing on 2 and 3. If N, then P, N, therefore P. 2, 3 modus ponens. And then, of course, we want to get to the consequent, which is O, N, P. Well, since O and P are on these two separate lines, I can use conjunction to join those together, like that. And so I started with the antecedent. I've made my way to the consequent. So now going back over here, I can draw the conclusion, if N, then O, N, P, based upon lines 3 through 6 as a conditional proof. Okay. So again, that's basically the way that it works for us. I think I'll do one more with you, just as an example here. So we'll take number 2. We have if F, then E. F and E, then R. Therefore, F, then R. All right. Well, this is another one of those that I would do very simply by using simplification on line 2, and it becomes if F, then R. But they want us to use conditional proof, so that's what we're going to do. We'll start with the antecedent, which is the F. Assumed conditional proof. Again, everything from here on is going to be indented to show that it's part of that conditional aspect. And now we just simply go up and try to solve our problems here. So we have lines 1 and 3, if F, then E, F, therefore E, 1 and 3 modus ponens. Now we have F on line 3, E on line 4. We can use conjunction to stick those together. And 2 and 5 make modus ponens again. F and E, then R. F and E, therefore R. 2, 5 modus ponens. And that's the consequent. So we've gone from the antecedent to the consequent using this. So back over here on our proper line, line 7, we can draw the conclusion, if F, then R, based upon 3 through 6 as a conditional proof. Okay, so that's the way it works. And I'm just going to let you do 3 through 5. So 7.5, section 1, 3 through 5, I'm going to let you do as homework on that. All right, and of course I'll be back to show you how it's done, so you can check yourself a little bit later. All right, have a good day.